Okay, so let's talk about radians. So it turns out radians are just another unit for angles. So just like degrees are units for angles, we're going to have radians. Mhm. Okay, but before we talk about radians, we need to talk about arc length. So an arc length is simply just, if we take a whole circle, right, and we have, at the center, I just go out to the edge of the circle, that's the radius. Well, if I put two of these down, you can see that I form kind of a little pie wedge or a pie shape, right, or a wedge shape, whatever you want to do, like a slice of the pie. Well, inside is theta. That's the angle, right, from both blue lines. And you can see on the outside, it actually, oh, sorry. So the actual angle on the inside, we call it the central angle. So think about it. It's in the center kind of these two lines. And then the outside actually forms a distance. And this is the arc length, right? So anytime from a circle, I can go from the center, I can extend out, create this little wedge shape. And then the outer part has a distance, and that's the arc length, all right? Okay, well, what's a radian is simply the measure of the central angle, so that theta, right, whose arc length is the same length as the radius of the circle, right? So I know that doesn't really make sense, but I'll show you kind of a diagram, or hopefully I'll walk you through it so it'll make sense. So here we go. Here we have our arc length in red. We have our radius right here, all right? So if my central angle, if that's 1 radian, so if this angle measures 1 radian, and again, remember, radian's an angle measure. It's like a degree. It just measures angles. Well, a radian says by definition, if this is 1 radian, then this length has to be the same as the radius. So this is 1 radius. So the blue length and the red length are the same, then this is 1 radian. All right, and we can go around the circle. Let's do two of these. Let's do two of these arc length, these two red, so they're going to be the same. Well, this is 2 radians because this length is two of these radii. All right, so that's how radians work. The measure of the angle, right? So 2 radians is the same as the distance across or around this arc length, in terms of the actual radius. So 2 radians, 2 radii. If I were to do another one, 3 radians would be 3 radii, right? And again, when I say that, it's the red distance is the exact same as the blue distance. All right, so that's a radius. Well, in itself, it doesn't seem all that impressive, but look at this. So what if I were to extend this line, again, when I said 1 radius, 2 radius, what if I just keep going until I do a whole circle? So that my arc length now is the entire perimeter of the circle, right? If that's the case, I don't know how many radians I have in this circle, but I do know the length, the perimeter of the circle. That's just 2 pi r. All right, so now our job is to figure out how many radians are in one complete circle. Well, easy, right? By definition, a radian, the number of radians is the exact same thing as the arc length with this radius, right? So that is the perimeter. So if I let the radius be 1, the perimeter, this entire red, is simply just 2 pi times 1, which is 2 pi. So the arc length is 2 pi. Well, by definition, the radians equal the arc length. So this theta is 2 pi times 1 radians, or 2 pi radians. So an entire circle has 2 pi radians in it. All right. Well, we also know that an entire circle has 360 degrees. So if both an entire circle has 2 pi radians and 360 degrees, then 2 pi radians equals 360 degrees. All right. And I abbreviated the radians with RAD. All right. So that's a nice equivalency right there. And that's what we're going to use a bunch of. All right. And notice if I divide both sides by 2, I'll get pi radians equals 180 degrees. All right. Okay. So you want to stop this and do class or problem 1. Okay. So now we can convert degrees to radians, radians to degrees. So let's take 60 degrees and convert that to radians. Well, 60, and remember that there are pi radians in 180 degrees. So this, since these are equivalent, this is really just multiplying by 1. And the trick here is I want to get rid of degrees, so I put the 180 degrees in the bottom, and I put the pi in the numerator. Right? And I'm always going to use this pi and 180 in this fraction, again, because they're equal, so it's really just a 1. Well, if you see it, 60 and 180, 60 goes into 180 3 times. So we can divide that out. But I'm going to split it up so in case you don't see it. So remember, 180 is 3 times 60. And then you can see the 60s, what happens to those? They divide out, right? They divide into a 1. So now it's just 1 times pi over 3. So this is pi thirds radians. All right, so 60 degrees, I multiply by pi over 180. I simplify my fraction, and I'm left with my angle. And then you got to put the radians, RAD, just like you'd have to put a degree symbol. Well, let's go backwards. Well, backwards, I don't know. Let's go from radians to degrees. So now I have pi fourth radians. So now I want degrees, so I put the degree on top, and I want to get rid of the pi, so I put the pi in the denominator. But again, 180, 180 degrees, and pi are equivalent. So anything divided by itself, this is really just a special 1. And now it's pretty easy. So see the pi's, they divide out, so they go to 1. So now it's 1 times 180 degrees, and then all divided by 4. And then 4 goes to 180 degrees 45 times. All right. Okay, so that's how we convert radians to degrees, degrees to radians. And again, the key here is using this pi over 180, either pi in the numerator, 180 in the denominator, or flip it, 180 in the numerator, pi in the denominator. But that's the one we're going to use for all the conversions from degrees to radians. Okay, so you want to stop this and complete class or problem 2A and 2E. All right, so now let's go back to our old stuff. Let's use reference triangles to evaluate, but now instead of sine of a degree angle, let's do sine of a radian. Well, since we've done degrees, why don't we just take our pi fourths and change it to radians? So again, pi fourths, so I want degrees. Oh, I'm sorry, I said change it to radians. It is a radian, let's change it to degrees. All right, and this 180 should have a degree symbol here. So it's 180 degrees in the numerator because I want degrees. I want these pi's to divide out, so that's why the pi is in the denominator. Okay, divide them out. Again, you have 180 divided by 4, so 45 degrees. So sine of pi fourths is the exact same thing as sine of 45 degrees. So our job is to draw 45 degrees, set up our reference triangle, which again, drop right down to the x-axis. Here's 45. This one's in the first quadrant, so it's easy. It is a special right triangle, so I'll use my unit circle idea. So I have hypotenuse of 1. Opposite is rad 2 over 2. Adjacent is rad 2 over 2. These are both in the positive direction, so I don't need to change the sign. And now sine of 45 is opposite, rad 2 over 2, all over 1. Remember, sine for a unit circle is always the y value. So sine of pi fourths is rad 2 over 2. Okay, so now we can do all of those, special triangles and their special, special angles and their reference angles, but now we can do them in radians. All right? Okay. So you want to stop this and do class art problem 3A. All right, the last thing now is, just like before, right, I said that we could take all our degrees and make them radians. That means this entire unit circle, right? I can take 30 degrees and convert that to radians, which is pi 6 radians. 45 degrees, I can convert to radians, pi fourth radians. So I can set up my unit circle so that it kind of reads out in both degrees and radians. All right. I don't know if I should state this or not, but a nice little trick. So see how 30, it's 30, then 60, then 90. So this increases by 30 and then 120. So if you wanted to, 30 is pi 6. So to go from this dot to this, it's just another pi 6. So here's 1 pi 6, 2 pi 6, and this would be 3 pi 6, 4 pi 6, 5 pi 6, 6 pi 6, 7 pi 6, right? 8 pi 6. So you can go around just like that. So you can fill out everything except for the 45 degrees by just increasing by pi 6 every time. And then the 45 degrees, same thing. 45 is pi fourths, so here's 1 pi fourths, and then double it, 2 pi fourths to get to 90, 3 pi fourths to get to 135, 4 pi fourths to get to 180, then 5 pi fourths, 6 pi fourths, 7 pi fourths, and then back to 8 pi fourths. So technically, you only need to know the 30 and the 45, and you can fill out this entire thing. All right? Okay. Well, that's it. So complete classwork 4A, and then when you finish, just complete the entire classwork.